Imagine you are working on a crucial application. Multiple users are trying to update the same inventory records or customer accounts simultaneously. You expect everything to run smoothly, but suddenly, your database operations grind to a halt. What could be happening behind the scenes to cause such a frustrating standstill? Yes, database transactions can absolutely experience deadlock. A deadlock is a specific, undesirable situation where two or more transactions are each waiting for a resource that the other transactions have locked, creating a circular dependency and a permanent standstill. This critical issue arises because transactions often need exclusive access to specific database resources, like rows or tables, to maintain data consistency. The conditions for a deadlock are quite precise. First, there is mutual exclusion, meaning only one transaction can hold a resource at a time. Second, there is a hold and wait condition, where transactions hold some resources while waiting for others. Third, there is no preemption, so resources cannot be forcibly taken away. Finally, and most importantly, a circular wait exists, where a chain of transactions is waiting for resources held by the next transaction in the chain, eventually looping back to the first. When these four conditions align, you have a deadlock. To prevent or resolve deadlocks, database systems employ various strategies. One common approach is deadlock detection, where the database continuously monitors for circular waits, often using a wait-for graph. If a deadlock is detected, the system typically chooses one transaction to be the victim, rolls it back, and releases its resources, allowing other transactions to proceed. A proactive strategy is deadlock prevention. This can involve enforcing a strict locking order, where all transactions acquire locks on resources in the same predefined sequence. Another method is using timeouts, where a transaction will automatically fail if it waits too long for a resource. Understanding the concept of a deadlock graph is incredibly insightful. This graph visually represents the waiting relationships between transactions and resources, allowing database administrators to pinpoint and analyze the exact dependencies causing the contention. It is a powerful diagnostic tool for optimizing concurrent access patterns within your applications. Another advanced technique is optimistic concurrency control, which assumes conflicts are rare and only checks for them at commit time, avoiding locks during execution. By grasping the underlying mechanics of deadlocks and implementing smart prevention or detection strategies, you can ensure your database applications remain as robust and responsive, even under heavy concurrent loads. This proactive knowledge is key to building highly available and performant systems that users can rely on.
If this helps you code smarter, like, subscribe, and stay tuned for more.